I'm Gabby.
And I'm Sam, and this is our Biotechnology's valve development project. So in the future, I want to be an engineer, so this kind of applies to me, although I'm not super interested in the biomedical field.
In the future, I want to be a forensics biologist. This kind of won't really help me, but it's fun.
All right, so first off, this is our final valve product. We had a couple demo tests with different versions, and we also had a separate prototype that was made by Gabby. And this ended up being the one that fell apart the least and had the best flow rate. So this just represents a heart valve. So here would be your valve that stops or allows blood flow, and then this would be different sections of the heart where you want your blow to get or get out of. So of course, leading up to this, we had a couple scrap designs. So as you can see here, these were images of some of our originals. So one of the first ones that was designed was this H valve, and the idea was that when it was flowing the right way, it would follow this path, but if you flipped it over, then it would go through a waste tube. And this didn't really work out because of the tape we were using. It just got stuck to itself when trying to make a tube. Then with the actual design that was made and used, there was 2 improvements made on it. Originally, the clip would have been right up by the marble, and the issue with that was that it held it too close, and so water wouldn't be able to get through. So when it would go the right way, instead of the marble being here, the marble was here, and it just held too tight to the valve, and water couldn't get through as well. And then the other issue with it was that the marble itself, when it was going the wrong way, was being pushed up by the water, and so it would collect water, and then it would lift up and drain, and then it would lower, collect water, lift up, and drain again, and it really wasn't working.
Okay, and then this was the last prototype that I made, and it really didn't work as well as this one because it falls apart more easily than that one, and the blood flow through it doesn't go too quickly. It kind of drains down the side and swirls down the tube, which is not the best thing for blood. And then whenever you flip it this way, if you look down in there, can you see down there?
There you go.
There is a blue flap. That is the flap to stop the blood. And then, so when blood comes this way, the flap falls down and clogs the hole in it. But I found out that hot glue is not water resistant, so the water came through where I hot glued it at. So that's why we didn't choose this one.
Although it is worth mentioning that one of the issues of mine was, again, that the marble was lifting up. And so when Gabby mentioned that she was going to use a flap in hers, I stole it like any good businessman was and improved it and put it into mine. And that ended up actually helping mine work. So mine has a 2 safety system.
And this one that I made actually had a prototype of itself. I had foam instead of this black plastic before, and it collected the water, so it didn't work.
You had a couple issues. Ours tend to fall apart a little bit, but so in the end, mine ended up getting chosen because it had easier blood flow. So you can see with Gabby's, the hole was a lot smaller compared to the valve that mine was going to go through. So that was just a material choice. And then obviously both of ours are not super resistant, but we found ironically that tape somehow works better than hot glue. So mine both fell apart less and was a little bit easier to repair.
Okay, so for the material, this is a rubber tube that we put the water through. And then this is the marble that whenever it goes the wrong way, it clogs the hole. And then this is the rubber flap made out of a glove to cover the hole. And then a lot of tape to hold everything together. And then down here, that is actually a paper clip that was spiraled and hot glue to hold it in place.
Yeah, and so when the valve gets wet, it will clog over the hole, and the marble makes sure that it falls in the right position. So now we're going to demonstrate it. So I'm going to hand the camera to Gabby. This is going to go well. All right, so this is the correct orientation. You can see the marbles at the bottom. So if we put this under, you can see the water getting through at the bottom, and that just represents that the blood flow is actually making it through. So if we flip this over now, you can see that the marble is going to clog the hole and the valve is going to be shut over it. And now if we put it through, it fills. So this represents the idea that the valve can close. Obviously in a body, the blood would be held in the area that was already in. This doesn't really, it has a holding tube here, but eventually it will overflow. So this motion of opening and closing and flipping it back and forth represents a valve in the heart opening and closing to allow blood flow.
So some of the problems with this valve is that the flap in there, it was cut a little bit short, so whenever you flip it back and forth, it could get out of place and it wouldn't be able to work. And the tape, whenever it gets wet, it likes to fall apart a little bit. So you have to tape it more to keep it in place.
And you can see the amount of layers on here because it is just pure white. So instead of being responsible students and taking the tape off and adding new tape, we just kept adding tape until it worked again. So one of the solutions we had for the tape was to try and use hot glue, but in Gabby's case, she actually used hot glue for her valve. So again, my valve actually really benefited from Gabby's because I learned that that was not a good thing. The hot glue really did not function underwater. And while the tape didn't really function either, the tape was both easier to repair than the hot glue, and it also survived just a little bit better. It's just if it got too wet, especially when the water was building up when it was going the wrong way, then it would start leaking through the sides, which you might actually have seen in the video. And then obviously fixing the flap would just be to make it a little bit bigger. The only issue with that was I really didn't want it getting stuck to the sides of the valve. And then for real life applications, the real issue with this is it relies on gravity. Inside the actual heart, you just have a valve that opens and closes based on muscles that allows blood to flow. But in this case, you have to flip the whole valve over. And so the first problem is obviously that's not how the body functions. You can't do somersaults to make sure that your blood's flowing. And at the same time, you'd never be able to sleep because if you laid back, suddenly your valve's entire function just goes down the drain. So in real world applications, it doesn't really work. But as for a demonstration, it does.
But this one doesn't work for that either. It doesn't work in the body.
Yeah, so both of ours are heavily based on gravity, which, I mean, you'd kind of expect in a little lab, but ended up working in the end, at least for a demonstration, and we're probably going to have to add more tape to this.
Yeah, more hot glue.
So that is it. That's our biotech project. We hope you enjoyed our little shenanigans. Thanks for listening.
Bye.
Bye.